Welcome to my next video, guys. In this video we are going to learn about the chapter solid state. As you know, when we talk of matter, it is subdivided into three parts: solid, liquid and gas. So we will divide this chapter into several halves and try to explain in details. In this part we are going to learn about the various types of unit cell and its features. So first we are going to learn about the primary unit cell. Please pause the video wherever you feel it to be necessary. In this primitive unit cell, the constituent particles are present only at the corners of a cube. A cube consists of 8 corners. Since each corner atom is shared by 8 unit cells, the contribution of each corner atom is 1/8 to the unit cell. Hence, the number of atoms in one simple cubic unit cell equals to 8 multiplied by 1 by 8 equals to 1. If you see the following diagram shared by me in the screen, you will understand the whole feature of this primitive unit cell. Please write it down, the details which I am sharing with you in the screen. So number of particles present at the corners equals to 8, and effective number of particles present equals to 1 by 8 multiplied by 8 equals to 1, where A is equals to edge length of the particles, R is referred to as the radius of the particle. Let us consider A is equals to 2R, 2 times the length of R. Volume of the particles equals to A cube, which means 2R cube is equals to 8R cube. Volume of the unit cell equals to 1 multiplied by 4 by 3 pi r cube equals to 4 by 3 pi r cube. And packing fraction equals to volume occupied by the particles divided by volume occupied by the unit cell. This is very useful formula. It will help you in the numerical. In this case, volume occupied by the particles will be 8R cube, whereas volume occupied by the unit cell will be 4 by 3 pi r cube, which will result to 2 by 3 pi where pi is equals to 1.414, which finally will result to 0.524. In our last case, there is another small formula which is named as packing efficiency, which literally means packing fraction into 100, which will result as 0.524 into 100, which will 52.4 percentage. Therefore, we can say that percentage occupied by the particle will be 52.4 percentage, and percentage unoccupied by the particle will be 46.6 percentage. Now we will learn about the body centered cubic, which is the BCC unit cell. For that, we have to firstly draw the diagram to understand its properties. In body-centered cubic system, the cubic unit cell consists of 8 atoms at the right corners and 1 atom at the center of the cube. Since each corner atom is shared equally by 8 unit cells and the atom present at the body center belongs wholly to the unit cell, the contribution of each corner atom is 1 by 8 and that of the body centered atom is 1 to the unit cell, and hence the number of atoms in a body centered unit cell will be 8 into 1 by 8 plus 1, which will result to 1 plus 1 equals 2. And now I will request you guys to copy the formulas which I am writing on the board. This will help you in solving the numericals. We have to take A as the edge length of the particle and R as the radius of the particle. In this case, it will be 4R is equals to root over 3A, where A is equals to 4R by root 3. Therefore, volume of the particles will be A cube equals to 4R by root 3 whole cube equals to 64R cube divided by 3 root 3. Volume of the unit will be 2 into 4 by 3 pi r cube, which will result to 8 by 3 pi r cube. To understand it in more details, I will later on share you the picture of the body centered cubic unit cell. But first, I have to complete the formulas and discuss it with you. For packing fraction, the formula will be same as that of the face centered and the primary unit cell. It will be volume occupied by the particles divided by volume occupied by the unit cell, which will equal to 64 divided by 3 root 3 r cube divided by 8 by 3 pi r cube, which will result to 8 root 3 divided by pi, which will result to 0.68. And we have to now find how to the packing efficiency, which is packing fraction multiplied by 100. In this case we have packing fraction as 0.68, therefore packing fraction will be 0.68 into 100, which will result into 68 percentage, and therefore we can say that the percentage occupied by the particles will be 68 percentage, and whereas percentage unoccupied by the particles will be 32 percentage. Now we will move on to the next type of the unit cell, that is known as face centered cubic unit cell, also known as FCC unit cell. In this, for that we have to make the diagram so that we can understand the properties carefully. In a face centered cubic system, the cubic unit cell consists of atoms at the center of each of the 6 faces and one atom at each of the 8 corners of the cube. Each corner atom is shared equally by 8 unit cells, thus contributing 1/8 to the unit cell. Each atom present at the center of the face is shared equally by 2 unit cells, contributing half to the unit cells. Hence, we can say that the number of atoms in a face centered unit cell will be 8 into 1 by 8 plus 6 into 1 by 2, which will result to 1 plus 3 is equals to 4 atom. To understand it more carefully, you have to copy the statements which I am writing it on the screen. For that, we have to take as A equals to edge length of the particle and R equals to radius of the particle. And for this, we will say that 4R equals to root 2A, which will result to A equals to 4R by root 2. The volume of the particle will be A cube, as it was done previously, which will result to 4R by root 2 whole cube equals to 64R cube divided by 2 root 2. And volume of the unit cell will be 4 into 4 by 3 pi r cube, which will result to 6 by 3 pi r cube. To understand this more carefully, I will share you the diagram of the face centered cubic system. Now again we will return to our formulas, that is the packing fraction. It will be the same as discussed before with you, that is volume occupied by the particles divided by volume occupied by the unit cell. In this case, for face centered cubic unit cell, it will be 64 r cube divided by 2 root 2 divided by 16 by 3 pi r cube, which will result to 4 divided by 2 root 2 into 3, which will result to 0.74. And for packing efficiency, it will be the same formula, that is packing fraction into 100. Here the packing fraction is 0.74. It will be multiplied by 100 to give 74 percentage. Please do like, share and subscribe this channel with others.